Hello class, welcome to this lesson on 4.4. We're going to be adding and subtracting rational expressions. Alright, so we want to be able to rewrite rational expressions to find sums or differences. So how do we go about doing that? So the learning goal is to be able to find sum or differences of rational expressions, and in doing so we'll need to find the least common denominator or the least common multiple of two polynomial expressions. Alright, so we're going to need to know what a least common multiple is and a least common denominator. So a rational expression involves an operation or operations between two or more fractions. In this case, we'll be focusing on expressions with addition or subtraction. So in order to add or subtract rational numbers, which are basically fractions, together, we'll simply need to add or subtract the numerators if the denominators are the same. So for example, if we wanted to find the sum or difference of 1 over 5 and 3 over 5, well, they have the same denominator. So in this case, we'll be able to add the numerators, or combine the numerators by adding them. So in this case, we'll simply combine the fractions under one denominator and combine the numerators on top. In this case, we're adding, so it's going to be 4 over 5. Pretty straightforward. And if it was subtraction, you would simply subtract the numerators. Now, similarly with variables, if you introduce variables into the mix, well, we have the same denominators here, so we can combine this under one common denominator and simply combine the numerators, in this case x plus 5. Alright, in this case we got our solution to the second one. Similarly for the third part, well, if you look at this looks a little bit different than this, right? But if you pull out the x, you can see that they're actually the same denominator. So what we can do is, we know that these have an x in common, so I can pull the x out. And if I pull an x from x squared out, that leaves me with x to the first power. And then I got a plus sign. And then if I pull an x from 3x, that leaves 3. So in this case, these are a perfect match. So now I can simply basically rewrite this as x times x plus 3 and then simply combine the numerators. In this case, we're subtracting here. So we got one denominator, a common denominator, and we have our numerators. So we have here 2x plus 1 minus 3x minus 8. And notice I'm careful to distribute, to put parentheses around this so that I make sure that I distribute the minus sign. In this case, I'm going to simplify a little bit. I have 2x plus 1 and then a negative 3x. And then I got two negatives here. When I distribute, we got a negative and a negative, which is a positive. So plus 8 over x times x plus 3. And then we can combine our like terms, simplify a little bit. So we have here 2x minus 3x is negative x. And we have 1 plus 8 is 9. So we have here 9 minus x over x times x plus 3. You can also write this as negative x plus 9 over x times x plus 3. And that would also be correct. Alright, so that's how you go about finding sums or differences of fractions or rational expressions given the denominator being the same. So in order to find denominator, or adding or subtracting fractions with the same with different denominators, we'll have to employ another method. But before we do that, go ahead and give this problem a try, and then we'll cover it in just a second. Alright, so let's go over the problem. They have the same denominator, so you can combine them under one common denominator. Make sure you distribute the negative sign here. So we have a negative and a positive 8 makes a negative 8, and a negative and a negative 4x is a positive 4x. And then we'll combine our like terms. We have a 10x plus 4x is a 14x, and a negative 5 and a negative 8 is negative 13. All right, and that's how you combine those two. So now, if we want to add or subtract fractions together with different denominators, well, we'll need to find the least common denominator, which in this case is the least common multiple of the denominators. So what is a multiple? A multiple is a number that can be divided by another number without having a remainder. So the least common multiple, or the LCM, involves finding the least number that can be divided by all the denominators without a remainder. Or in this case, not just denominators, in this case all the numbers that you're looking at without a remainder. So in this case, we need to find the least common multiple. So if we have two numbers and we want to find the least common multiple, well, we'll simply factor the numbers. So we'll have 6 breaks into 3 times 2. This is a prime factorization. So you continue to factor it until you get to prime numbers, and you can't factor it anymore. In this case, 6 is 2 to the first power times 3 to the first power. And if you did 15, well, 15 breaks into 3 times 5, which in this case is pretty straightforward. It's 3 to the first power times 5 to the first power. So in this case, in order to find the least common multiple, what you're going to have to do is you're going to list out all the factors, which in this case are 2, 3, and 5. So you're going to combine all the factors, and then you're going to pick the highest number for each factor. So in this case, I have a total of 1, 2 here, and I have no 2's on the right side. So I'm going to pick 1, 2 from the left side. And then I have on the left side, I got 1, 3. On the right side, I have 1, 3. So that means I'm going to pick 1, 3. I want to pick the highest power from each side, or from each number. In this case, it's 1. And then on the left side, I have no 5's, and I have 1, 5. So I'm going to pick 1, 5. Alright, so I'm going to pick the highest power. So if, for example, this one was a 2, then I would make this 3 to the second power. Alright, but in this case, neither of them were squared, so I would just leave it as to the first power. So now I simply multiply the results together, 2 times 3 times 5, and I get 30. So in this case, my least common multiple is 30. Now, if I don't have any numbers and I have, just variables, well, I'm going to do the same principle, right? I'm going to factor it, but this time I can't use a factor tree. I have to, factor using other methods. In this case, I can factor this using an x table. And I know that I need the factors of 6 that multiply to 6 to add up to 5. So two numbers that multiply to 6 to add up to 5 would be 3 times 2, and then 3 plus 2 is 5. And then I can simply factor this as x plus 3, x plus 2, using those two numbers that I found. Now this is already factored, so I don't have to do anything to that. So, because remember, this is the same thing as x plus 2 times x plus 2, which is already factored. So now I can find the least common multiple. So again, list out all the factors here. Well, I have an x plus 2 right here, and I have an x plus 3. So I have one x plus 3 here, so I'm going to give this to the first power, and that's the most. And I have two x plus 2's here, and that's the most. So I'm going to pick that. And there's my LCM. It's the most of each factor. And I can really erase this 1 because that doesn't really do anything to the problem. And that's my least common multiple. Alright, let's look at the third part just to make sure that we get it. So this time we have 3 different expressions, and we'll have to find the least common multiple. So we're going to have to factor each expression. In this first one, you can pull out an x since they have an x in common. So if we pull out an x here, we'll simply get, we'll write it out here. We pull out an x, we get x times, and then in parentheses, if I pull an x from x cubed, well, that leaves me with x squared. If I pull an x from 9x, well, that's simply 9, and there's a negative in between. Okay, so that's sort of this first part, but this part can actually factor even further, right? So we can actually do that even more. So in order to factor that part, well, notice that you can also do an x table here. In this case, negative 9 on top, and since there's no middle number, Like if you look at this one has a middle number right here. But this one does not. So therefore the middle number is 0. And my two numbers here are 3 and -3. 3 times -3 is -9. It has to multiply. And it has to add up to 0, which in this case is 3 and -3. Or you can look at it as a difference of squares, and it will lead you to the same result. So we can factor x plus 3 and x minus 3. So now that is completely factored. Now here we have to factor this again using an x table. So this one has a middle number right here, so that's going to go down here. It's going to add to that, and it's going to multiply to -15. So we need two numbers that multiply to -15 to add up to -2. In this case will be 5, 3, and then it has to be a -2, so the bigger number has to be negative, so it's going to be -5. So -5 plus 3 is -2, and -5 times 3 is -15, so I can go ahead and factor. So I have x and then minus a -5, and then x plus 3. That's a positive 3. Alright, so that's factored. Now let's do the last one here. I'm going to adjust this. So now this I can pull out an x. So I'm going to pull out an x times, and then if I pull an x from x squared, that's x. If I pull an x from 5x, that's 5. So -5 here. Alright. Now, so this is completely factored. So now that we have everything factored, I'm just going to go ahead and basically, I'm going to box these. This is not our answer. This is not our final answer. I just want to make sure that I emphasize that those are the factored forms. Now we'll have to find the least common multiple. So let's list out all the unique factors. Well, I have an x, right? So I'm going to write that out. I have an x plus 3, so I'm going to write that out. I have an x minus 3, so I'm going to write that out. And I also have an x minus 5, so I'm going to write that out. Okay, so I have all those factors and nothing else. Some of them are repeats, right? So I have at most one x on the left side, no x's on the middle. Remember, I'm talking about x's by themselves, right? Not like with another number with it, like a -5 or something like that. And then I got one x here. So I'm going to pick the most as 1x, so x to the 1 power. And I have an x plus 3 on the left side and on the middle and not on the right side. And they both have 1. So I'm going to pick the one with the most. They both have 1, so it's just to the 1 power. X minus 3 to the 1 power. Again, that's the one with the most. And then I have the most, x minus 5 is 1. Alright, so they all have 1. So really I can just erase the 1. I just wrote that so that you know that I'm using, one of each. And therefore that's my LCM, since that's the most of each factor. So remember, the least common multiple has all the factors that all the expressions have and the most of each factor. So now that we found the LCM, we can go about finding the least common denominator, but before that, go ahead and try the following example. Alright, so let's go ahead and find the least common multiple of the first one. Now again, this is not, there's no variables involved, just numbers, so we'll have to factor the numbers normally using a factor tree. So 8 is 2 times 4, and 4 is 2 times 2. 20 is 2 times 10, and then 10 is 2 times 5. So we have here 3 primes and 3 primes. So 8 is 2 to the 3rd power. There's 2 3s, or 3 2's here, right? So that's a total of 3 2's. So 2 to the 3rd. And here we got 2 2's, so that's 2 to the 2nd. And then we got a 5, so times 5 to the 1st. So the LCM is, again, all the factors. So we got a 2 and we got a 5. And then you're going to pick the most of each factor. In this case, the most is 3 2's, and the most is 1 5. So there's my LCM. We'll have to do 2 times 2 times 2, which is 8, and 8 times 5 is 40. That's my least common multiple. So now if we don't have any numbers, if we just have variables or polynomials in this case, we'll have to factor this. So in this case, this is a cubic polynomial. However, we can factor it using a technique known as factor by grouping. I'll just shorten it as FBG. So you may remember how to do this. If not, just go ahead and follow along. You're gonna place two groups basically by putting them in parentheses. There's four terms, so two each. You're gonna pull from each group. So what can I pull from the first group? Well, they both have two x's in common, so I'm gonna pull two x's out. So I got x squared, pull that out from the first group, and then that means I have 1x left, and then plus, and then if I pull a x squared from 9x squared, well, that's just going to be 9. All right, that takes care of that first group. Now we got plus. Now for the second group, we can pull out a 27 that they have in common. Pull a 27 from 27x, that's just x, plus pull a 27 from 27, well, that's going to be 1, because 1 times 27 is 27. So now that we, so this actually cannot be, now that I think about it, cannot be factored this way. All right, oops, folks. This should be a 9, not a 27. So I apologize for that. So you won't be able to use factor by grouping if that weren't a 9. So go ahead and make that correction. So now we can pull out a 9. We're going to pull out a, oh, I'm sorry, not a 9, a 3. Should be a 3. So if we pull out a 3, we could pull out a 3 from 9 and 27. In this case, we'll get 3 times x is 3x, and then 3 times 9 is 27. Okay, so I'm going to make that correction. I apologize for that. So now we got x plus 9 is actually one of our factors. And then the other factor is going to be x squared plus 3. Okay, in that case, you'd be able to factor that. Here we have, we're going to use an x table for that. In this case, we have negative 21, and then on the bottom is negative 4. So two numbers that multiply to negative 21 that add up to negative 4. Well, in that case, that'll be 7, 3, and then it had to be negative 7 because negative 7 plus 3 is negative 4. So this will be x minus 7, x plus 3. So in this case, the least common multiple, we're going to have to list out our unique factors. Looks like there's 4 unique factors: x plus 9, x squared plus 3, x minus 7, and x plus 3. So we're going to list them all out. They're all unique. And then we multiply them together, and that's our LCM. Notice that there's one of each of them at most, so this is it. This is our least common multiple. All right, so we're going to use the idea of the least common multiple in terms of denominators. So if you're doing it for denominators, we call it a least common denominator. Still the same thing, still the same idea, find the least common multiple. So in order to add or subtract rational expressions with different denominators, we're simply going to factor each denominator, and then we're going to find the least common multiple and use this as the least common denominator. We're going to find the least common multiple of each denominator, and then we're going to multiply the numerator and denominator of each fraction by something. Now this something has to convert the denominator to the LCD. We'll see how this looks like in a second. Then we're going to combine the fractions under one common denominator and simplify. So before we do this, for this example, let's look at this for the example, the simple example maybe of 1 over 4 plus 1 over, and we'll try, let's see. Let's try 56, just to make up an example. So now, if we factor 4, so these are different denominators, so we won't be able to combine them. So if we follow the first step, factor each denominator, well, 4 breaks into 2 times 2, 56 breaks into 7 times 8, and then 8 is 2 times 4, and then 4 is 2 times 2. So these are all my prime numbers. So if I want to find the least common multiple, which in this case I'm going to call the least common denominator, because we're looking at denominators here. Well, this is 2 squared, right? And this is, let me write it up here. This 4 can be written as 2 squared. This 56 can be written as 7 to the first, using the 7 there. And we got 3 2's. So 2 to the third. So we're going to pick, we have 2 times 7. We're going to pick the most. So 3 2's and 1 7. Well then, do 2 to the third times 7. Well, that's just 8 times 7, which is 56. So in this case, the least common denominator was 56. So in order to do this then, in that case, we'll have to multiply each denominator by something to convert it to the LCD. Well, in this case, 4 times what will give you 56? In this case, 4 times 14 will give you 56. And then what times 56 will give you 56? Well, it's just going to be 1, right? Times 1. And then you're going to do the same thing to the top, right? So if I multiply the bottom by 14, I got to do the same thing on top. Same with the next fraction. So that's really the third step. Multiply the numerator and denominator by something that converts the denominators to the LCD. So now these are both the LCD, 56, right? So I get 14 times 1 is 14. So I have 14 over 56 plus 1 over 56. Then you combine the fractions under one common denominator and simplify. So in this case, combine the fractions under one denominator and simplify. 15 over 56. In this case, if you can reduce it, then you would reduce it. And now that's what we would call simplifying. In this case, we're done. So we're going to do the same thing here, using those 4 steps, but just with variables. So if we want to find the sum or difference of part A, well, we have to factor. So step 1, we have to factor the denominators. Now this one, we have x squared minus 1 is going to be x plus 1 times, so it's going to be a difference of squares, or you can use an x table, negative 1 on top, 0 on the bottom, because it has no middle term. 2 numbers that multiply to negative 1 that add up to 0 would be 1 and negative 1. Now this one, you could do an x table as well, and you'll have 2 on top and negative 3 on the bottom. So then we have 2 numbers that multiply to 2 that add up to negative 3 would be negative 2 and negative 1. So these both factor. So the bottom factors out as x plus 1, x minus 1. The second one, x minus 1, x minus 2. Alright, so we got this step 1 done. Step 2, we're going to find the least common denominator. So again, we list out all the unique factors. Well, I have an x plus 1. I have an x minus 1. I have an x minus 2. And I got a repeat, so I'm not going to repeat it. Now, I have one of each at most. So I have these are all to the first power. Okay? But I'm not going to write it anymore. I'm going to go ahead and erase it because it doesn't really matter that the 1 is there. So I have one of each, so therefore that's my least common denominator. Now, step 3, I'm going to convert each of those denominators to the least common denominator. So I'm going to rewrite the expression here. I'm going to replace these denominators with their new factored denominator. This gets replaced with what we factored here, x minus 1, x minus 2. So then you gotta figure out, well, what am I missing? What do I need to do, multiply, to convert this denominator to this LCD? Well, if you look at it, we're actually missing an x minus 2, right? So I'm going to multiply this by x minus 2 and do the same on top. And then if you look at the second fraction, the second denominator, I'm actually missing an x plus 1. So I'm going to give it an x plus 1 and do the same on top. And now, notice that both denominators match, and they're both equal the least common denominator. So now, step 4, I'm going to combine this under one common denominator. Since these denominators are the same, I can combine them into one denominator. That's the next step. So I have 1 common denominator of x minus 2, x plus 1, and x minus 1. It doesn't matter the order of the factors in the least common denominator. You can put them in any order that you like. And then the numerator is going to be, well, I have x minus 2, x plus 3. I got a plus sign there, so I got to add it. And then I got the second numerator, 2 times x plus 1. Then step 4 is just do a lot of simplifying. So step 4 is the big simplification step. So we'll go ahead and do that over here because there's a lot to be done for step 4. So we'll have to FOIL this first part. So we have x times x is x squared, first, outer, inner, last. So first terms, outer, x times positive 3 is 3x. Inner, negative 2 times x is negative 2x. And last, from FOIL, negative 2 times 3 is negative 6. So we FOILed that first part. And then the next part we'll have to distribute the 2. So we have plus 2x plus 2 times 1 is 2. Over, at this point I'm going to call this least common denominator because I don't want to write that denominator multiple times until the very end. Okay, so now we're going to have to simplify this. So we got x squared plus 3x minus 2x. So we have here, that becomes a 1x. And then 1x plus 2x, that gives us 2x. And then we have the negative 6 plus 2 is negative 4. So we have x squared plus 2x minus 4. Now I can go ahead and write out the least common denominator as such. Alright, so again, we're simplifying here, so we'll have to see if this factors. If this factors, then in this case we'll have to factor it. But you got to test to see if it factors first. So we need to find factors of negative 4 to add to 2. Well, in this case, this does not factor because negative 4 and 1 is going to give us negative 3, or 4 and negative 1 is going to give us 3. And then if you did 2 and 2, well, that's going to give us 0. So this does not factor. So we cannot factor this. So we are done here. You don't have to do anything else. All right, so again, I'll repeat that part. If you have a numerator at the very end, see if it factors, just in case, and then factor it. If not, you are done. Okay, so the step 4 is definitely the most time-consuming step. You have to factor and all that stuff and distribute. All right, so for part B, we're going to do the same thing here. So step 1 is to see if it factors, see if all the denominators factor. Now this first denominator does not factor. There's nothing that you can do to that to make it any simpler. The second one does factor. So we're going to factor that. Now in order to factor this expression here, this polynomial, you're going to have to use the AC method. So you're going to have to multiply the a and the c together. You can't go straight to the x table because you have a number here. If that number were not there, then you can go ahead and use the x table. However, if there's a number there, you're going to have to do a little bit more work here. So you're going to multiply the a and the c together. I call that AC method. And then you'll get negative 24. Then you can use that number in the x table. So negative 24 on the top and 5 on the bottom. So now you can find two numbers that multiply to negative 24 but add up to 5. In that case, that would be 8 and negative 3. So this factors. You can't factor this right away. What you're going to have to do is you're going to have to split this middle term into those two numbers that you found. So this 5x is going to break into 8x, positive 8x, and then negative 3x. Bring down the rest. So this is a positive 8x, this is a 6x squared, this is a negative 4. Then you're going to have to factor by grouping and then pull from each group. So from this first group, I can pull out a 2, I can also pull out an x. So I'm going to pull out a 2x here. So 2x times 3x is 6x squared. I got a plus sign here. 2x times 4 is 8x. So that's done. Now for the second part, I can only pull out a negative. So I'm going to go ahead and pull out a negative 1. Negative 1 times positive 3x is negative 3x. Negative 1 times positive 4 is negative 4. I go ahead and distribute to make sure that it makes sense. So now that these match, I can rewrite this factor once, the one that repeats, and then the 2x minus 1 in the next parentheses. So now they factor, and this is how it looks like. Alright, so now we're ready to find the least common denominator. So we have this, and we have the first denominator of 3x plus 4. So let's go ahead and find the least common denominator. Well, they both have a 3x plus 4, so I'm going to give it that. And they have one of each, so I'm just going to take the most, which is 1. Alright, you're not going to combine them and make them 2. So only going to be whichever one has the most. And then you got this one has a 2x minus 1, the other one does not, so you're going to give it 1 2x minus 1. So that's my least common denominator. Step 3. We're going to convert the fractions so that they have the same least common denominator. So we have 2 over 3x plus 4 minus 4x squared minus 11x minus 12. And then I'm going to convert that denominator. I'm not going to rewrite that denominator. I'm going to rewrite it the way I factored it earlier, like that. So now if I compare this to the least common denominator, well, I know that this first fraction is missing a 2x minus 1. So I'm going to give it a 2x minus 1. And then I got to do the same thing on top. Whatever I do on bottom, I do on top. And the reason why I do that is because now these basically cancel out. So it doesn't really do anything to the problem. But of course, you're not going to cancel it out because that would be counterintuitive, right? Like that would be counterproductive here because, you know, you'll be back where you started. Now this second denominator you can't do anything to since it's already matching the LCD, or you can simply times it by 1, but that doesn't really do anything. So we'll leave it there. So now step 4, now that they have the same, you know, denominator, the least common denominator, you're going to combine them under one least common denominator. In this case, you're subtracting, so you got the first numerator minus, and then the second numerator, you're going to put that in parentheses so that you're careful about the negative signs. So now we're simplifying at this point, so we can distribute the 2 here. So we got 2 times 2x is 4x minus 2, 2 times 1 is 2, minus, now you're going to distribute the negative here. So negative 4x squared, and then a double negative for the 11 makes it positive 11x. The double negative for the 12, because you got a negative here, negative there, is going to be positive 12. So now we can put this over the LCD, and then we're going to simply combine the like terms here. So I got a 4x and an 11x I can combine. That makes 15x, and then I got a negative 2 and a negative 12 that I can combine, and a positive 12 I mean, and that makes 10. And then I'm just going to rewrite this negative 4x squared. So I'm going to rewrite the negative 4x squared first because I like the highest power going first. And then plus 15x because 4 plus 11. And then the negative 12 plus 2 plus 12 is positive 10 over, now I'm going to write the LCD as such. And then I got to make sure that this does not factor. So I'm going to double check that. So I'm going to double check to see if the AC method works here. If not, I am done. So I got to make sure I multiply 4 times 10, that's negative 40. And then I'll need 2 numbers that multiply to negative 40 but add up to 15. So 2 and 20 is not going to work here. 1 and 40 is definitely not going to work here either, even if they were negative. 4 and 10 is not going to work, although that's very close. 5 and 8 is not going to work, although that'll also be very close. And that should be it. So there are no other factors. So this does not factor at all. So we're going to ignore it and call this the final result. Now the reason why I check to see if it factors is because if you have two of the same factor on the top, one on top, one on bottom, they can cancel. So for example, if this factored as, let's just say for instance, it factored as negative 4x plus 1. And I'm just making this up, right? So let's just say it factored as x plus 1, or like let's say it factored as 2x minus 1 and negative 2x plus 10 or something like that, just to make something up. Well, in this case, the 2x minus 1's match, and so now I can cancel them out, top and bottom, because they're the same, and then this would be my final result. So this is why we factor it, just to be safe. Okay, in this case, there's nothing that we can do in this problem. All right, go ahead and give these following two problems a try. I'll give you about a minute or so before we cover it. All right, so hopefully you paused the video and gave yourself, a minute or two, or however much time you needed to solve the problem. All right, so for part A, you're going to have to factor. So this one factors using an x table, and so does the next one. So we have negative 4 on top, 0 on the bottom, since it has no middle term, which is 2 and negative 2. This is also the difference of squares, x plus 2, x minus 2. Same deal. Now this one also factors. So we have 6 on the top, negative 5 on the bottom. Two numbers that multiply to 6 and add up to negative 5 would be negative 3 and negative 2. So they're factored. I can replace them. This would be an x minus 3, x minus 2 using the x table. And then this would be an x plus 2 and an x minus 2. All right, so step 1 is completed. Step 2, we're going to be looking at the factors. So LCD, well, they have an x plus 2, they have an x minus 2, and they also have an x minus 3. They have one of each, so put them together. That is my least common denominator. So now, step 3, we're going to basically convert each of these so that they have the same denominator, the least common denominator. So if you look at the first fraction is missing an x minus 3 as such, right there. So we're going to have to give it an x minus 3, do the same thing on the top. Now the second fraction is missing an x plus 2 there. So we're going to have to give it an x plus 2. Do the same thing on the top though. Alright, so now they have the same denominator. We can combine them under one denominator. And we're going to do that on the right side here. So we got one common denominator, x minus 3, x plus 2, x minus 2. Again, it doesn't matter how the order in which you write the factors, the parentheses, still be the same. On the numerator, we have x plus 6, x minus 3. Then we have plus the second numerator. So then we're going to simplify. So we got a FOIL here that we'll have to do. So we got first, x times x is x squared. Outer, x times negative 3 is negative 3x. And we got an inner, 6 times x is 6x. And then a last 6 times negative 3 is negative 18. And then we got distribute plus 2x plus 4 all over, and then we'll just write this as LCD. We're going to combine our like terms. So we got x squared. There's no other x squareds. We got a negative 3x and a 6x and a 2x. So negative 3 plus 6 is 3. 3 plus 2 is 5. So we got 5x. Negative 18 plus 4 is a negative 14 over least common denominator. And then we got to see of the 14 factors. So we got negative 14 and 5, which sneakily enough, it does factor. This is why you need to check just to be safe. So negative 14 factors into 7 and negative 2, which is very sneaky here. So because it factors, it's going to change the problem slightly. So x squared plus 5x minus 14, that's going to factor into x plus 7 and x minus 2 over x minus 3, x plus 2, x minus 2. Now this is why I told you need to check to make sure that it factors, because there's a chance that they have the same factor. Now they have the same factor. If you notice that they have that same x minus 2 there. So I'm going to go ahead and cancel that out because they have that in common. So then my final result is x plus 7 over x minus 3 times x plus 2. Alright, let's look at the next one. There's another part to this. So let's find the, again, same deal. We're going to find the least common denominator. So we're going to have to factor. So 3x factors into 3x, nothing more, nothing less. 6x factors into 3 times 2x, because 3 times 2 is 6, and those are primes. And an x squared is just x squared. So step 2, the least common denominator, well, we have a 3, we have a 2, and we have an x. So which one has the most 3's? Well, both of these have the most 3's, so just to the 1 power. This one has the most 2's at 1. 1, 2. This one has the most x's at 2 of them. So our least common denominator is 6x squared. So in this case, and I'm just going to do a step 3 up here just to save a little space. This right here is missing a 2x to make 6x squared, so we're going to do the same thing on top here. This right here is missing an x, so we're going to do the same thing on top. And this is missing a 6, so we're going to do the same thing on top. So we'll do a step 4 here. So we're going to combine them under one denominator of 6x squared. 1 times 2x is 2x. We got a plus x minus a 6 over 6x squared. And then 2x plus x is 3x. So we have 3x minus 6 over 6x squared. And then we'll just simplify a little bit. So we can pull a 3 from the top. So we get 3 times x minus 2 over 6x squared. And then how many times is, well, this is a fraction, right? 3 over 6. So you can reduce that, divide by 3 in top and bottom, and that becomes a 1 over 2. So we have an invisible 1 here, which we won't write, over 2x squared. 6 divided by 3 being 2. Alright, and that's it for the lesson. I hope you learned something from this, took something from the problems, and I'll see you in the next video.